Let's talk about the big picture. How is parallelization going to lead to greater adoption? So maybe we can start with Keone.
Sure. Parallelization is a technique that ultimately raises the throughput of blockchains. And I think in order to achieve mass adoption for any single application, like for any app to hit #1 in the iOS App Store, we need a lot more throughput, and parallelization is just one way of addressing that.
So, for example, in the normal financial sector, you have dates where banks need twice the usual throughput, like Black Friday, or in China during I think October something, where it's Chinese national, and they need to provision twice the capacity, and it reaches 15,000 TPS, billions of dollars of sales in Amazon or Alibaba.
Let's imagine classical database, because blockchain is a classical database in fact, but distributed. Have you seen ever a normal database that are not allowing parallelization? Usually no. So mostly it's not a question, is it a preliminary condition to mass adoption or not? It's a question when it will be ready to use for adoption. So it's obligatory condition for that.
Yeah, I would agree with everything that's been said. What I'd add to is I think what parallelization offers zooming out is being able to bring Web 2 scale to Web 3. So removing a big part of what's rate limited, the ability for Web 3 infrastructure to support a lot more use cases, right, beyond the ones that we've seen to date. So I think that's really the promise here. And I think all the various implementations that we're talking about is all an effort to bring that Web 2 scale into Web 3.
I think it totally makes sense that parallelization is all about increasing capacity, but one of the main criticisms is when you do that, you also increase complexity and therefore risk. So what are some of the risks that you see, and how is the type of parallelization that you're using to mitigate that risk?
Yeah, so I'll speak specifically to Eclipse's implementation, which is using the Solana VM for execution, settling to Ethereum, and using Celestia for DA. So you can think of it as Solana on Ethereum. You're tapping into Ethereum users and Ethereum assets, but the developer and app and user experience feels like Solana. Longer term, our research direction is really going to lean into really increasing that TPS above and beyond even what Solana is able to increase it to, because we're specifically in L2, right? So in L2 does not have to worry about security considerations of the L1. And we plan to do that through hardware acceleration and really hardware-software co-design and these types of things. And so specifically for Eclipse, to answer that question, I think the risk is less in security and more in complexity of the DevX or developer experience, right? Because reentrancy is not possible, but from a DevX experience, with Solana, accounts can only be modified by their owners. And so as a developer, you need to account for all the accounts that have been touched and factor those in as input. So the complexity of that whole developer experience is significantly higher, and I think that's probably more the consideration for Eclipse.
I would say it's not an issue in parallel execution itself, because you can just launch several EVM instances and execute transactions in parallel as much as you'd like. But there are two issues, basically. How to persist all changes in single state and do it without any issues. And second, when you have a parallel execution, you have to broadcast a lot of data to synchronize how you executed in parallel all your transactions. And it's much bigger block size usually you have than a normal Ethereum block. And I would say Solana, coming back to Solana mentioned here, Solana solved it by splitting blocks into small chunks, synchronizing, broadcasting these small chunks, and synchronizing not the whole block, but small pieces. I would say Solana solved this issue and risks very well. And I don't know, I guess currently it's the best parallelized solution in the market and battle tested. And they mitigated this risk in this way.
I see two risks in parallelization. The first one is, well, usually people think serial is simpler than parallel. So now you already have lots of bugs, millions of dollars of bugs with serial execution. And well, one of the questions is, do we trust if people start to use parallelism to write proper contract, proper execution, or proper VMs? Well, we, as you said, we have Solana that's battle tested, so that solves one part of the problem. The second part is the size of the state. It's that Solana publishes a lot of transactions per second, and then people who run archive nodes have an issue because they are growing by terabytes very, very frequently, and no one can store that data unless they are professional, and it costs a lot. So this removes part of the decentralization aspect of Ethereum. So I don't think this can fit on Ethereum L1. So you have to use layer 2 so that they post short proofs, short state updates to give the Ethereum as a settlement layer still runnable by, well, people memed about Raspberry Pi, even myself. I did a talk on Ethereum 2 on Raspberry Pi in 2019. People moved away from Raspberry Pi, but still we do want mini PCs.
Talking about Monad specifically, so Monad is a fully Ethereum compatible layer 1, and the block format in Monad is the same as Ethereum in the sense that all the transactions are linear. There's a completely well-defined order. And the job of optimistic parallel execution in Monad is to run many transactions in parallel, but ultimately produce the same result as if they'd just been run one after the other. That's the guarantee of the algorithm, and there's bookkeeping that's done in this optimistic parallel execution algorithm that keeps track of the inputs and outputs for each transaction and only commits pending results if the inputs have not been mutated, and reschedules work if it needs to be done. So there's not a safety risk per se in the optimistic parallel execution relative to just serial execution, but just more generally risks in Solidity smart contract development. We're all really familiar with reentrancy attacks, and I think there the benefit is that with much cheaper gas, developers can write many more defensive assertions and just be more cautious and basically defend invariants that are expected in the contract.
Great. It sounds like there's a lot of different layers and where the risk needs to be assessed and approached differently. What types of, so there were some examples already, but what types of ecosystems or specific applications do you think benefits the most from parallelization? So I think there was an example about e-commerce, but is there gaming, is there AI, are there specific verticals that this might be built up more?
Yeah, I think anything that's aspiring to mass user adoption does actually need much higher throughput than we have right now. So for example, if you imagine someone playing RuneScape and they pick up 50 items over the course of an hour, if each of those item pickups is a transaction and that's a tenth of a cent, then someone playing for an hour would end up spending 5 cents on gas in order to do that, and that seems totally reasonable. But with the existing landscape of layer 1s or layer 2s, 50 times 1 cent or 50 times 10 cents becomes a really unreasonable number for someone that's just playing, doing something that's a non-economic activity. So our team feels strongly that consumer applications need much more throughput, and parallelization is one way to address that.
I guess for Taiko, one of the vertical that we're very interested in is gaming as well. So people in game want responsivity. We look, if you look into all the gaming media, they talk about the speed of the screen, the speed of the GPU, and then you go to blockchain and it is 12 seconds block time. And I don't think we can attract this crowd with the kind of speed that we have today.
Generally speaking, all applications will benefit from it. For instance, you can have DeFi application if applications want to use shared resources between each other. They can be executed separately. It means, for instance, launching meme coins won't affect any games or DeFi applications. So all type of verticals will benefit from it. But in particular, I guess like we see a very good example on classical Web2 market, financial applications. And all of them utilize parallelization because it's standard de facto in this area. And I anticipate the same for DeFi sector. I guess the first DeFi sector will benefit from parallelization.
I'd like to answer to this. So one of the competitors of all of those blockchain were based on the UTXO model, and they had issues with modeling something like a DEX, like Uniswap. I think Ergo with ErgoDex kind of fixed this, but I don't hear about it that much nowadays. But there's an issue when you have a pool of resources and lots of people tapping into it, because then you get concurrent state updates, which is one of the hard problems even on normal computers.
Yeah, I think with DeFi, obviously that's been kind of one of the primary areas that we've seen app development to date in Web3. But I think the kind of edit I'd make is that you can have a lot of these high performance DeFi applications existing on the same chain or network. I think the paradigm we've shifted to most recently is that every high-performance DeFi product is trending towards having its own Cosmos app chain or app-specific rollup. I think being able to have these apps coexist on one network without having to worry about the noisy neighbor or hotspot problem is the promise of parallelization, right? And Solana has proved that in large part to date. I think beyond that, super excited about consumer as well. And then I think DePIN is another long-term area that's going to be super interesting from a high TPS perspective, and just super interesting use cases around sensors and AI and similar spaces.
I think the wish is that there will be more consumer apps, but then more people using those consumer apps. So I think everybody on the panel is a couple steps removed from that actual adoption, but working on the base infrastructure that leads to that. So this question is for Yuriy and for Vijay, because I kind of see your projects as like opposites, like SVM parallelized to EVM, EVM parallelized to SVM. So I'm really curious why like one method was chosen over the other, and like what the pros and cons of each are.
Yeah, I'm curious to hear Yuri's take, but I think from my perspective, the answer is actually not that spicy in the sense that we're also partners, and so basically with Eclipse, we wanted to focus specifically on the performance and high TPS angle, and so we felt that the architecture of implementing the SVM for execution and settling to Ethereum was the best of both those worlds, right? Because from a first principles perspective, you're sort of getting the highest TPS capability, and then you're getting access to the largest user and asset base in crypto still, which is on Ethereum. So that was our architecture, but where we felt Neon was a really valuable partner is in terms of tapping into the traditional Solidity developer audience, right? So Solidity still has a much larger developer community, much larger network effects, and so really being able to tap into that and help bring Solidity developers over to the SVM was our goal in that partnership. Because I think there's not a lot of overlap between Solidity and Rust developers for the most part. I think that's slowly changing, but I think it's also largely a philosophy and school of thought that really keeps those two separate, or has to date.
Continue this message. Let's say we are both utilizing Solana, and pros of this is like Solana, as already mentioned, it's the first battle tested parallelized execution layer and storage layer for sure. And it has battle tested for 3 or 4 years, don't remember exactly. But upon that, we are providing, let's say, EVM compatibility layer, because there are a big difference between Solana community and Ethereum community in number of dApps. On Solana, you have just 250 apps. On Ethereum side, more than 30,000 of apps, if I'm not wrong. And it shows how easily Ethereum developers can launch their applications in comparison with Solana. But at the same time, you need, if Ethereum developers would like to step into Solana world, they need EVM compatibility layer. And at Neon EVM, we are providing this compatibility layer. And let's say the most technically difficult, or the most hard thing we solved, it was optimistic execution upon Solana layer, something that Ethereum community has been discussing for several years. We implemented it upon Solana execution. And this, I would say, these pros and cons we experienced in real mainnet, because we've been working for 1 year in mainnet. And pros, I would say, it's a real parallel execution. All base layer of Solana works well, and Ethereum layer upon it works well too. The only cons of it, it's Ethereum application usually designed to be run in sequence, not in parallel. It means most of the Ethereum applications are not ready for parallelization itself. Especially if they're using, most of them are using shared resources or shared variables. In this case, Ethereum developers need to adopt it for parallelization. And this is main drawback of parallelization, but I guess it's a matter of time for ETH apps to be ready for that. And this is pros and cons.
That reminds me that I forgot to mention one risk. It's the fact that people are used to the EVM and not the parallel part. And one of the things that we're developing at Taiko, and we mentioned in DevConnect in Istanbul, but we were busy to release our mainnet 1 month ago, was the base booster rollup part. So instead of parallelizing at the EVM, SVM, the VM level, we want people to spawn EVM on an as-needed basis. So apps can subscribe to 1 booster rollup, 2 booster rollup, 3 booster rollup, and we have execution sharding. And then we post proofs, ZK proof, in that case, to avoid optimistic delay. Yeah.
Okay, great. So the markets have not been great recently. So I'm wondering if you guys can tell us a little bit more about what you're most excited in your roadmap in the next 6 months that can maybe make us all a little more optimistic.
The Monad team is actively working toward a public testnet.
Well, I just mentioned it, the base boot rollup. That's our end game.
I would say 3 things. First, it's adopting EVM applications to parallel execution and showcasing them to the market, providing interoperability with Solana itself, so being able to call from Neon EVM any Solana smart contracts and vice versa, and building SVM rollups. Yeah.
Yeah, and for me in Eclipse, we have mainnet launch coming up later this summer, so that's something that we're super excited about. And then I think more generally, excited to see the launch of these high-performance networks sort of help to draw in developers who really want to build game-changing net new apps, right? I think right now the infra is definitely leading net new app adoption and net new developers, but I think that's going to change, and that's something I'm super excited about too.
And then for our very last question, what is something that is not currently being built, but you think is necessary to get us to mass adoption for blockchain?
Like infra or apps or anything?
Anything.
Yeah. So obviously there's a lot going on with infra now. Super saturated in general, but I think a lot of exciting stuff going on. I think for me, it's really seeing improvements with wallet design in general to really help make a lot of that connectivity and just kind of a lot smoother from a user perspective, right? Because I think if that happens, then you sort of enable everything else, and it's easier for the users, right? But really seamless bridging experience. I think the Backpack team has done a good job of this historically, and just really making that UX seamless for retail, and becoming like a one-stop shop as well.
I would say the similar things like simplifying user journey and user onboarding path, including wallets, and somehow get rid of this secret phrase without compromising security. So it would be great to have this in place for upcoming mass adoption.
I was thinking exactly the same as the other two. Like, do you like using MetaMask? That's kind of the question. Regarding removing secret phrase, people couldn't even remember passwords, so they put those on the post-it. It's a big issue even in normal Web 2. I know that at the IETF, Internet Engineering Task Force, they tried to standardize something called PACI for passwordless authentication. But it's been 7 years and it's not being shipped. Google is trying some WebAuth, Fido, etc. But things are moving super slowly. I don't know if we can push it as well in the blockchain space.
Just one remark. I interviewed a lot of products to my team and asked question, what do you think is the most, the best from user experience side product in Web3? And 80% of products answered MetaMask.
We need new people in product then.
Yeah.
So I actually have 2 things. The first thing is I think we need much better benchmarking of different scaling solutions and layer 1 environments so that it's much more clear to developers what the actual best performance and best option is among different technology providers. And then I think the second thing is we need one huge success story among either a commerce, like a Web 2 commerce company or Web 2 game moving to Web 3 and basically just killing it in terms of their go-to-market from that. to then cause other traditional companies to just get really excited about and take the leap, because it is a bit of an investment to switch your Web 2 brand to add a Web 3 component.
Yeah, I think most of the Web 2 brands who've made kind of a step towards Web 3, it's always a little bit like gimmicky, or like it's something just on top of it. It's not actually a deep integration. And
Yeah, we need someone to just absolutely kill it.
So I've got several examples from the French companies and others. I know that the French gendarmerie, so something similar, military police, used to pay sources through Tezos. The one for mashed potatoes, a company for mashed potatoes called Mousseline put some mashed potatoes on the blockchain as well. And you had AXA, which is an insurance company who collaborated with Air France for delayed flights. So that was a bit more serious, I'd say. And the last one was LVMH. So Louis Vuitton, they worked with Consensus to do clothes on blockchain so that people could track where they came from. But like they did those POC and then I guess they shelved the team and never communicated about it.
okay, great. And then let's do a lightning round. One word to describe to blockchain and crypto in the next year. Let's do year.
A year or 3 years?
Hopefully not dead in 3 years, but
Okay,
let's do year. A little longer.
Anticipating.
Okay.
Execution, product execution.
ZK?
I would say with the upcoming election, winds of change.
Ooh, okay, great. So with that note, thank you so much for joining today, and thank you so much for joining EthScale. That's our last panel for today.
Thanks for having us.